Okay, so this one's for cosecant, and it's in the form y equals a cosecant bx. So think about a cosecant curve, and what does it look like? Well, remember the cosecant, you get your asymptotes right at 0, one's at 0, and then out here at 2 pi, and then we'll put pi here in the middle, you're going to end the period with another asymptote. Okay, and then there's one in the middle. So I'm kind of showing you this to help you with the graph. I'll show you this in a little bit. So I'm kind of like going, okay, what's the beginning of the period? What's the end of the period? And then we go halfway in for the other asymptote. And then we're going up here at 1 and down here at -1. And so it looks very much like the secant curve. So you're going to think, okay, what's halfway between 0 and pi? What's halfway between pi and 2 pi? There's no phase shift here. This is just a basic one. And so it's going up like this, and then it's going down like that. Okay, so that's the basic one. Now let's look at what we have over here on our function that we're going to graph one period for. So we see the absolute value of a is 3, but it will reflect this time. So it's going to reflect about the x-axis. Okay, and then what about the period? Okay, so the period is equal to 2 pi over 4, which is going to be pi over 2. Okay, now, in an earlier video, I talked about placing those asymptotes. So in this case, there's no phase shift. So your asymptotes are going to be at pi over b, k, where k is an integer. That means k is an integer. Okay, so you think about the integer, oh, our b is 4, right? Okay, so pi over 4, and then think about k being 1, and then k being 2, and then k being 3, you know, and so on and so forth, right? Okay. Okay, so, you know, you kind of have an idea of where these asymptotes are going. But I wasn't going to use that. I was going to show you a different way. Okay, we'll draw this out. Now, remember, for this example, we just have a reflection going on, we have a stretch factor, and then we have a change in the period. Okay, so that we have to keep in mind. All right, so let's say pi over 2, right? Okay, so there's no phase shift, so I'm just going to mark this as pi over 2. And that is the end of the period. So that means I'm going to have an asymptote right here, and I'm going to have an asymptote right here. That's the end of the period. Now think about cutting that in half. We did this with some other graphs earlier. So that's going to be pi over 4, and we're going to have an asymptote right there. Okay? So we see this period like closing in a little bit. It's getting like closer together, right? It's like a horizontal compression. Okay, now you might say, yeah, but you don't have an asymptote at 0 over here where you have the asymptotes written out. Well, if k were 0, that would be 0, right? And so you do have an asymptote at 0, and we have one at pi over 4, and we have one at pi over 2. And this is enough to graph one period, so we're okay. Now, what we have to do is put in the stretch factor. Okay, so we're going up 1, 2, 3, and we're going to be going down 1, 2, 3. We don't have to worry about a vertical shift because there isn't one here. We do have to worry about the reflection, though. So what used to be up here is going to reflect about the x-axis, and so it's going to be down here at 3. I'm sorry, down here at -3, and going that way. And then up here at 3, so we get that stretch going on and going this way. And the reflection, okay? So that would be the graph.